All right, I'm going to discuss the example in this section. I think that's the first example or second example of this section. So this section is the marginal functions in economics. We're talking about cost functions and profit functions. So this example is about profit, okay, and the marginal profit. So it says Acrosonics production department estimates that the total cost in dollars incurred in manufacturing X electrostat speaker system in the first year of production will be this. So this is the cost function, okay. The total cost of manufacturing X units of this electrostat speaker. So that's the total cost. It's denoted by C of X equals 200 times X plus $300,000. Okay, so X is the number of production, and so this gives the total cost for the year. And then the marketing department has determined that the demand function for these speakers is P was negative 0.04x plus 800, where P denotes the speaker's unit price in dollars. So remember, the demand function is the price from the customer as function of the sale X of the sales. Okay, so P is just the unit price for each speaker from the customer side. So we need to do three things. In this example, we need to find the profit function P in part A, and we need to find the marginal profit function P prime. And then we need to compute the marginal profit function P prime at 5,000, 8,000 for X. Okay, the 5,000 and 8,000 units of sales, basically. So let's just do this part by part. The profit function is the revenue function subtract the total cost. Okay, so when you calculate the profit, you need to consider both the revenue and the cost. Okay, so we know the cost function is this, it's given. So when you find the revenue function, the revenue is just the unit price P times the sales X. So that's just the P times X. All right. So let's just do the okay. Okay, so so the profit function, we usually use P to denote it. As I said, that's the difference of the revenue and the total cost. Okay. The revenue is just the unit price P times the sales X. Okay. So we have already given P equals negative 0.04x plus 800. So just plug that in for P. So we need the parentheses. Okay, so negative 0.04x plus 800, that's just PR copied from the previous page, times x, the sales, and then subtract the total cost. Okay, so then what? We can plug in things, you know, term by term. Okay. I don't know why we got anyway. And so then we can just distribute x in the first part. So we got negative 0.404 x squared. And plus 800x. Okay. The second term, and then subtract. And the total cost C, which is 200x plus 300,000. Okay. All right. So then we can, distribute the negative sign in the second part and the combined like terms. Okay, so that will make everything negative in the second part. Okay, so that's just the linear function, but we can do a little further step to simplify and the combine like terms. Okay, so we got negative 0.04 x squared in this first term, and then 800x minus 200x, they are like terms. So 800 minus 200, we got a 600x, and then minus 300,000. So that's the revenue function, the first part. Okay, so that's good. Then we need to find the marginal profit function. So the first part is the total profit. We already find profit function. The marginal profit function is just the derivative of the total profit by definition. Okay, so that's what it means by marginal. Okay, whenever you see anything saying about marginal function, it means the derivative. Okay, so here we're trying to find the marginal profit. So that's just the derivative of the profit, total profit. Okay, so let's just take the derivative of the profit function, which we already obtained in the first step. So just do it step by step. So we're going to take the derivative negative 0.04 x squared, and then negative 600x and 300,000. Okay. let me just put all this forms here. Oops. Okay, so the first term will be -0.04x squared. When you take the derivative of that, and the second term is 600x. The third term is just 300,000. Okay. All right. So, okay. This derivative is pretty straightforward because everything is just a power function. So the first step, we can take out the constant from the terms. So if you take out -0.04 from the first term, then we got the derivative of x squared, isn't it? And we know how to do it. Okay. And then the second term is just 600 times x squared, x prime. Okay, and the third term is just a 0 because we know the derivative of constant it's always 0. All right. So we already did this kind of problems before. We know how to find the derivative of x squared and the x. So I'm not going to repeat all the details about it. But it's just the 2x when you take the derivative of x squared. Use the power rule. X to the n, the derivative of x to the n is just the n times x to the n minus 1, where n here is 2. So the derivative of x squared is just 2 times the x to 2 minus 1. So 2 minus 1 is just 1. So that's 2x to the 1, but the x to 1 is just x. So we got 2x from the first term, and the derivative of x is just 1, as we know. Okay, so then if you simplify it, -0.04 times 2 is -0.08. So the first term is -0.08x. And the second term is just 600. So that's the marginal profit. Okay. Now we still need to do a this third part of the question is the compute the marginal profit function at x equal to 5,000 and at x equal to 8,000. So let's just do it one by one. So when you find the p prime of 5,000, I believe. So just plug in 5,000 for x in this marginal profit function. Okay, so that's -0.08 times 5,000. Oh, wait, oops. Oh, well. Sometimes it doesn't work the way it should be. Here we see it. So we got -0.08 times 5,000 minus 600. If you multiply 0.08 with 5,000, you're going to get what? 400, I believe. Okay. Oh, I'm sorry. I got a sign wrong. So the second term should be plus. Okay. So 800 minus 200 should be positive 600. So everything in the 600 should be plus. Okay, so we get positive in the second term instead of negative. That will change everything. Okay, sorry about that. So now let's just multiply those numbers. 0.08 times 5,000. I think that's negative 400. If you do it, we got negative sign in the front. Okay, then you add 600, so that gives 200. Okay, right? And then we need to do the marginal profit function at 8,000. So x equal to 8,000. So we just plug in 8,000 for x instead of 5,000. Okay, so again, just plug in numbers and figure out the answer. So negative 0.08 times 8,000. I think that's negative 640, if I'm right. That's right. So then you add 600. So that's equal to negative 40, isn't it? So that's the answer for P prime of 8,000. So you can see, the marginal profit is positive when x equal to 5,000. When the sale is 5,000 units, you still make some profit. It's positive, 200 per speaker. But when you sell more, as the sales reach 8,000 units for the whole year, then the profit becomes, the marginal profit becomes negative. So you don't make any money. You lose $40 for each speaker. So, so you don't want to say sell it anymore. And the reason for that is the price goes down. Okay, so you don't make more any money actually. So that's the end of this example.